All right, so today we are going to be on 110, which is on solving inequalities. Our learning target is to solve linear and quadratic inequalities and write it in interval notation. So we have this rule about inequality signs and when you switch them and when you do not. The rule says when you multiply or divide both sides of an inequality by a negative number, we have to switch the inequality sign. So when you add or subtract both sides by a negative number, we don't switch the inequality sign. Only when you multiply or divide both sides by of an inequality by a negative number do we switch the inequality sign. So let's come down here to the first example here. Our first example here says solve each linear inequality, express in interval notation, and graph on a number line. So our first one there is 3x is less than 9x plus 4. Well, let's go ahead and let's solve that just like we would normally. So what do we have to do? We have to bring the 9x over on one side with the 3x. So I'm bringing my x terms over on the same side of the inequality sign there. So on the left-hand side there, we get a negative 6x is less than 4. Notice I did not switch the inequality sign because I subtracted 9x from both sides. Only when I multiply or divide both sides of an inequality sign do I switch, by a negative number, do I switch the inequality sign. Well, I went ahead and I subtracted. The next step here, I have to get rid of the negative 6 next to the x. It's attached by multiplication. It says negative 6 times x. To get rid of the negative 6, I'm going to have to divide both sides here by negative 6. Notice I just divided both sides there by negative 6. So this time, what am I going to do with the inequality sign? I'm going to switch it because I just divided both sides there by a negative number. Now, look at that negative 4, 6. That can be reduced down. I'm thinking, oh yeah, 2 goes into both of those. 2 goes into 4 there's twice. 2 goes in the negative 6 there, negative 3 times. So I end up getting a negative 2/3. So I just solved it. I'm supposed to express the answer there in interval notation and then graph it on a number line. So I'm going to go ahead and put a negative 2/3 here. It says it has to be less than negative 2/3. So it's not equal to negative 2/3, so I have to put an open dot. And then it's less than that. Less than is on this side. The numbers are smaller on this side. So there it is. I've expressed it on a number line. Now I have to put it in interval notation. So interval notation here goes on forever in the left. That's negative infinity. And then I've got a negative 2/3. It's an open dot. So I'm going to use a parenthesis there. So with negative infinity, we always use a parenthesis. If it's an open dot, we use a parenthesis. So there's I've done both of those things. I had to graph it on a number line and write it in interval notation. Parts B and C, very similar to that one. We've got 6 minus 2x is less than or equal to 14. You want to get the negative 2x by itself, so get rid of that 6. It's a positive 6 right now. It's attached there by addition there. We have to get rid of it using subtraction. So we end up getting a negative 2x is less than or equal to 8. My next step here is to get the x all by itself. So this time, negative 2 and the x there are attached by multiplication. We're going to have to divide both sides by negative 2. Notice this time I went ahead and I divided both sides of the inequality there by a negative. So I'm going to have to switch the inequality symbol there. So I end up getting x is greater than or equal to negative 4. So now it says x is greater than or equal to negative 4. This time it's equal to it, so I've got to have a solid out there. And then I have to shade into the right because it's greater. So how do I write that in interval notation? Well, interval notation, it's starting there at negative 4. It's included, so this time I'm going to use a bracket. And then it goes through infinity, so we have to use what goes on this side? Infinity. And then what symbol goes on that side? Parenthesis, because infinity and negative infinity are always with parentheses. You don't literally see an infinity on the number line, so it's not an actual value. All right. And then let's come down here and look at part C here. We got negative 1/4 times x is less than or equal to 32. We have to get that negative 1/4 out of there. You could divide both sides there by negative 1/4 if you wanted to. Some people have a hard time putting that in their calculator correctly, so it's also hard to do it in your head. So what I do to get rid of that negative 1/4 times x there, to get rid of the negative 1/4, I multiply by the reciprocal of negative 1/4. The reciprocal of negative 1/4 is negative 4 over 1, or just negative 4. So negative 4 over 1 times negative 1/4 there. A negative times a positive is a positive, so I'm just going to end up with an x over here. Notice I just multiply both sides by a negative. So if I multiply or divide both sides of an inequality sign there by a negative, I have to switch the inequality symbol. So 32 times negative 4 there ends up being a negative 128. All right, so let's graph this out on a number line. It says greater than or equal to negative 128. It's equal to it, so what kind of dot goes at negative 128? Okay, good. Solid dot. And then it's greater than negative 128, so do I shade into the left or shade into the right? It's greater than, so we're going to shade into the right. So then my next step here is to write that inequality there in interval notation. It's starting there at negative 128, and then we shaded it into the right there, so that's infinity. So make sure it's in that order there. So it's including negative 128, so we put a bracket around that. It's going, it's getting larger and larger through infinity there, so infinity always has a parenthesis with that. All right, so then letter D here, we're going to solve each linear inequality here, so let's keep going with this one. So this one here has a couple x's in there, x terms, and it has two constant terms. So let's move the x values on one side, and I usually like x on my left-hand side, so I'll usually move it there. So I'm going to subtract 7x. So I get a negative 2x minus 6 is greater than 28. Notice I subtracted 7x on both sides, so I didn't switch the inequality symbol. I'm going to get rid of the minus 6 there, so I'm going to add 6 to both sides. Adding doesn't switch the inequality symbol. And then I have to get rid of the negative 2. The negative 2 is attached to the x there by multiplication. I have to divide to get rid of the negative 2 next to the x. Now that I'm dividing there, I am going to switch the inequality symbol there. So now let's go ahead and graph the solution here out on a number line. So it's less than, it's not equal to it. So what kind of a dot goes there at negative 17? All right, an open dot. And then which way do we shade it in, to the left or to the right? Because it's less than, we are going to shade it into the left. All right, so now we just have to write our solution there in interval notation. It says express in interval notation and graph on a number line. So it's going through negative infinity there, so it's parenthesis, negative infinity, comma, negative 17, and negative 17 there has an open dot, so we put a parenthesis. Again, it has to be in that order. And then we've got one here where we've got kind of a between statement here. Again, you have to just solve here for x, so you need to get the x term all by itself. We could pull this apart if we wanted to and make this into two statements if that's helpful to you. So then I can do the negative 2 is greater than or equal to 5x minus 18, and then and 5x minus 18 is less than negative 1, and solve each of those if I wanted to, or I could solve it together. If I solve this separately, we would just go ahead and just solve this as is. You just do it exactly how we've been doing it. You would add 18. You get 16 is greater than or equal to 5x. You'd get rid of the 5, divide by 5, and you get 16/5 is greater than or equal to x. And then I just switch everything around, switch the inequality symbol because it's backwards. Read from the x's perspective, x is less than or equal to 16/5. The other one over here, you could do the same thing. Add 18, add 18. You get 5x is less than 17. Get rid of the 5 next to the x, divide by 5. You get x is less than 17/15. All right. The other way of kind of working through this, and then we'll talk about this in a minute here, and this is an and statement. The other way, you could just kind of leave it together if you wanted to and solve it. So if I leave this together here, I have to get this 5x by itself, so I have to add 18. If I add 18 on the inside, I have to add 18 on the two ends as well. So over here I get 16, and over here I get 17. All right, so now I have to get rid of the 5, so I have to divide everything in here by 5. And I get x 16/5 and 17/5. All right, so now we can just sort of talk through this a little bit. You might want to have to graph this one out to kind of understand what's going on. Might help us to figure out what our solution here is. So now you have to think about which number is larger and which one is smaller there. Well, 16/5 is the same thing as 3 1/5, and 17/5 is the same thing as 3 2/5. So 16/5 is definitely the smaller value there, so it's going to go on the left-hand side on my number line here. So I'm going to do that. 16/5 and 17/5. So this one over here says x is less than or equal to 16/5. It's equal to it. So I'm going to put a solid dot there. It's less than or equal to it. So I'm going to shade in over here to the left there since it's less than. And then my other one there says that x is less than 17/5. So I'm just going to kind of go above the line here so you can see what's going on. That has to be an open dot. And then we're shading in to the left because it's also less than. All right, with an and statement there, whether it's together or whether it's separate, you're looking for the overlap. And the overlap happens to be right in here. All right, so what is that really? That really means that x there has to be less than or equal to 16/5. So then how do we write that interval notation? We would say parenthesis, negative infinity, comma, 16/5, and it's a bracket. All right, and then we could go ahead and we could regraph this out if we wanted to. 16/5, close dot at 16/5, and shade in there to the left there. All right, so you can either pull it apart or keep it together, but then just notice the signs aren't in the same order there. That's kind of the clue, is to tell you that something strange is going to happen odd with this answer here, because most time when you have two values here connected and the x there is in the middle, you know it's a between thing, and you just put the 16/5 and the 17/5 and you shade in between them. Well, the symbols there aren't in the same direction, so you know it's going to be kind of a different answer. So we're also going to solve some nonlinear inequalities. So the ones we've been working with are linear inequalities because your x terms there are just x to the first power, so 3x and x and 2x and negative 2x. We're going to look at some nonlinear inequalities. So here are some steps here. So we're going to be looking at probably some quadratics here first. So you want to move all terms to the left side of the inequality sign to make the right side equal to 0. And then you want to factor that left-hand side. And then you want to determine the values for which each factor is 0 and list those intervals determined by these numbers. And then using test values, we're going to make a table or diagram of the signs of each factor on each interval and then solve. So let's do one that's kind of easy here. So everything is already on one side, so it's already set equal to 0, so we don't have to move anything. That was step 1. Move all terms to one side and to get 0 on right. Move all terms to one side to get 0 on other side. And I usually move everything. I usually move all my terms to the left side because I like my x's on the left because it just makes more sense. And then 0 there is on the right side. Step 2, what we want to do is we want to factor. So let's go ahead and factor over here. So x, what multiplies to give me 6 and adds to give me a -5. Oh yeah, -2 and a -3 multiply to give us 6 and add to give us a -5. So then step 3, we want to find our zeros here. So how do you get 0 here? How do you get 0 there? Oh yeah, x equals 3 and x equals 2. So those are going to find where factors equal 0. So we found those. It's at 2 and at 3. Notice it's a less than symbol. It's not a less than or equal to symbol. Because it's a less than symbol, that 2 and that 3 there, they're actually going to have open dots there. All right? So far, so good. Now let's come down here to step 4 here. I think we're on testing. Let's double check here. Are we testing already? So using the test values, make a table or diagram of signs, and then we're going to solve. So there's our values there. So now let's kind of pick a test value. So you want to pick a test value over on the left side. So what's something that's less than 2? Maybe my test value here is going to be x equals 1. In between here, something between 2 and 3, maybe 2.5. Something larger than 3, maybe like 4. Those are our test values. All right. So what you want to do here is you can either put the 1 back up in the original equation and substitute the 1 in for your x value. So you could do 1 squared minus 5 times 1 plus 6 and see what your value is. Or you could put the 1 into the factors, 1 minus 3 times 1 minus 2, however you want to do that. I personally like to put it into the, it kind of depends. Sometimes I like to put it into the original and sometimes I like to put it in the factored. Sometimes it's easier for me to do it in my head if I put it into the factors. So if I did that, for instance, I'd do 1 minus 3 times 1 minus 2. Well, 1 minus 3 there is -2. 1 minus 2 there is a -1. I multiply that, I get a value here of 2. And so is 2 less than 0? No. So I'm not going to shade in that region that's over here on the left. All right, so let's take the test value in the middle here, 2.5. So if I plug that in, 2.5 minus 3 and 2.5, minus 2. So this gives me a -0.5. This gives me a 0.5. When I multiply those together, I'm going to get a -0.25. Is -0.25 there less than 0? So when I'm looking up here, is that less than 0? Yeah, it's less than 0. So I'm definitely going to shade this region in. All right, and then I could test my other value over there. It's a 4. I could put it in 4 minus 3 and 4 minus 2. 4 minus 1, 4 minus 3 there is 1. 4 minus 2 there is 2. When I multiply, I get 2. Is 2 less than 0? No, 2 isn't less than 0, so I'm not going to shade in this third region over here. All right. Sometimes you can also do this. Some people just like to kind of look up here. If I choose 1 here and I put it in here, when you did your test in here, you did 1 minus 3 there, you got a -2. So it's a negative. And when you did your 1 minus 2 here, you got a negative. And a negative times a negative there is a positive. Is a positive less than 0? No, it's not. So you can look at your signs there too that way as well. So then if you put in 2.5 minus 3, I'm going to check the middle one here, you end up getting a negative. 2.5 minus 2 there is a positive. A negative times a positive ends up giving us a negative 0.25. Is a negative value less than 0? Yes, it is. So that's why we shaded in that region. All right. So this is where we test values in those regions. And then step 5 down here, we wanted to solve. So we already did that. So now we've graphed it on the number line there, but now let's write it out in interval notation. So it's a parenthesis, 2, 3, parenthesis. That's our solution there. So again, you got to kind of know those steps as you're going through these. It makes it a lot easier if you just steps